Hello student, in this lecture I will discuss about fully controlled bridge circuit with resistive load. Okay, so let's start our discussion. In the fully controlled rectifier configuration, the average DC load voltage is controlled using two thyristors per half cycle. Thyristor 1 and thyristor 2 are fired together as a pair during the positive half cycle, while thyristor 3 and thyristor 4 are also fired together as a pair during the negative half cycle, that is 180 degree after thyristor 1 and thyristor 2. Then during continuous conduction mode of operation, the four thyristors are constantly being switched as alternate pairs to maintain the average or equivalent DC output voltage. As with the half controlled rectifier, the output voltage can be fully controlled by varying the thyristors firing delay angle. So now we see the operation of this fully controlled bridge circuit with resistive load. So it basically consists of four thyristors T1, T2, T3 and T4. During the positive half cycle, oppositely placed thyristor, that means T1 and T2, which are diagonal to each other, are in forward bias condition, and during the negative half cycle, SCRs T3 and T4s are in forward bias condition. Its operation principle may be explained in two modes. So in first mode, that means during the positive half cycle of the supply voltage, thyristor T1 and T2 are in the forward bias condition. When the triggering pulse is given to these two thyristors simultaneously, the load current flows through the path like L, T1, P, load R, T2, then N. At the instant omega t equal to pi, source voltage is 0. Load voltage is 0, load current becomes 0. So the thyristor T1 and T2 are naturally commutated. Now see second mode of operation. So second mode means during the negative half cycle of the supply voltage, thyristor T1 and T2 gets turned off naturally. At an instant omega t equal to pi plus alpha, when a triggering pulse is given to thyristor T3 and T4, which are in the forward bias condition, the load current flows through the path and T3, P, load R, T4 and L. So in this way, thyristor T1 and T2 are triggered at a firing angle alpha during positive half cycle, and T3 and T4 are triggered at the same firing angle alpha during negative half cycle. So this is the associated voltage and current waveform of fully controlled bridge circuit with resistive load. Now we will discuss about fully controlled bridge circuit with RL load. The single phase fully controlled bridge circuit with RL load is shown in this figure. Its operation of principle is during the positive half cycle of the supply voltage, the thyristor T1 and T2 are in the forward bias condition, and thyristor T3 and T4 are in the reverse bias condition. To ensure simultaneous firing of T1 and T2 pair and T3 and T4 pair during positive and negative half cycles of the supply voltage respectively, they should be triggered from same firing circuit. In this mode, T1 and T2 conduct, that means during positive half cycle. The load current follows the direction as L T1 P load R T2 N. Here the load current is assumed to be constant. At the instant omega t equal to pi, the supply voltage gets reversed, but due to the presence of larger value of load in inductance, the current, that means the load current, is maintained in the same direction with a constant magnitude. Hence the thyristor T1 and T2 are in the conducting state, though the supply voltage reaches 0. Now see the second mode of operation, that means the negative half cycle. So during the negative half cycle of the supply voltage, the thyristor T3 and T4 are triggered simultaneously at an instant pi plus alpha. With this, the thyristor T1 and T2 are commutated by the negative line voltage, which reverse biases them through the thyristor T3 and T4 respectively. In this mode, the load current follows the path like N T3 P load R T4 L. At the instant omega t equal to 2 pi, the thyristor T3 and T4 are still in the conducting state due to the presence of load inductance as described before. By the control of phase angle of the firing pulse, which is applied to the gates of the thyristor in the range of 0 degree to 180 degree, the average value of the DC voltage can be changed from positive maximum to negative maximum continuously. With fully controlled converter, two modes of operation is possible. Okay. The average DC voltage is reversible even though the current flows in one direction. So as a result, the power flows in the converter in either direction. So when fully controlled converter works, then two modes of operation is possible, and these two modes are rectifying mode and inverting mode. Okay, so first we will discuss about rectifying mode. In rectifying mode, during the interval alpha to pi, the supply voltage ES and load current I0 are positive, and hence power is delivered from source to load. During the interval pi to pi plus alpha, the supply voltage is negative and the load current is positive, which results the power to flow from load to source. But the net power flows from source to load as pi minus alpha is greater than alpha. Okay, so for alpha less than 90 degree, the power flows from source to load, and hence the circuit acts as a rectifier. Okay. Now see inverting mode. So when the SCRs are triggered at the firing angles alpha greater than 90 degree, inverting mode of operation takes place. In this mode, the net power flows from load to source. The voltage and current waveform corresponding to rectifying mode and inverting mode are shown this figure. This is the voltage and current. This is the voltage and current waveform of rectifying mode, and this is the voltage and current waveform of inverting mode. Okay. Now here I have derived the average output voltage of fully controlled bridge circuit with RL load. Average output voltage and average output current here I have derived for fully controlled bridge circuit with RL load. Okay, and I also have derived the RMS output voltage of fully controlled bridge rectifier with RL load. Okay, so thank you.